All right, we are live. Hi everyone, I'm really excited to host Zakaria Djebbara. He's an architect and cognitive neuroscientist. And when I heard about his research work about ER, VR, and EEG, I thought I should get him on the show. It's an amazing work. So thanks a lot, Zach, for your time to do this.
Thank you for inviting me. I'm really looking forward to this discussion, this interview.
Yeah. So Zach, can you walk us through your journey from your undergrad and like how you grew interest in this field?
Yeah, sure. Perhaps I should maybe then go a couple of years back because I'm currently a postdoc, which means that I have finished a PhD position and successfully defended it and so forth. But actually, my journey started way before my PhD. I actually started during my master's, sort of questioning my capacities as an architect, whether I feel comfortable actually drawing some architecture, and how would people feel about my architecture? How would I affect their life? I mean, they're going to spend every day in my drawing, basically. So I guess there was a lack of comfort in the drawings that I would make because I simply didn't know about the effects. So once I actually started looking into what do we know about the effects of architecture, I realized rather quickly that the research field, or let's just say culture of architecture, is very poor. In fact, we don't know very much about the effect of architecture. And it partly is because we don't know what architecture is. Everyone thinks that they have their own definition. I typically refer people to the Arc Daily article that has, I think it's called 121 definitions of architecture. And you will have a long list of different architects discussing what do you think architecture is. And yeah, it's interesting that several of these architects, they reoccur. So I guess they don't even agree with themselves. So we probably don't know what architecture is, and we also don't know how to investigate it. And I thought, maybe I need to look into some of these things. And essentially, that's what I did, right? So I started looking into psychological theories. I started looking into spatial perception, environmental psychology, you name it, really, because since architecture typically does not have anything to sort of offer other than the built environment, you sort of have to link it up with another field, another study, and then you try to understand architecture through that perspective. And in my case, it became like psychology, and eventually more neuropsychology, and essentially it became cognitive neuroscience. So that's sort of my. Actually, this was a brief story about how I got into it.
I see. And like that's quite interesting. And I would like to know, like, once you found that you had this interest in this field, can you like share some advice, like how did you navigate in this field, like about research, knowledge, people to work with?
Yeah, that's an excellent question. So I guess I identify as a what I call a three-column scientist, right? So I like to think about a lot of things when I do research. To me, the most important part is the question, and you start from the question. From the question, you sort of figure out the nature of your question, and then you have some kind of hopefully you have a horizon of options, and you sort of navigate the options, right? So in my case, where I started was trying to understand the effect of architecture. Simply, what does the built environment do for us? And eventually I started looking into, well, there are some conceptions about space, right? And we have very naive conception of space, that certain spaces can cause certain effects. And I started thinking, well, I don't think that that space will always cause that effect. And I think there's a lot of other things, a lot of other parameters that are sort of having sometimes a more a greater impact on us than other things. So essentially what I did was that I started to identify as a three-pillar researcher, right? So I started looking into the theory that would cause me to develop certain hypotheses, and I would try to simulate these hypotheses, and I would also try to experiment with these hypotheses, right? So I have a philosophy direction, and this is very clear in my PhD dissertation. You can see that very clearly. So the first part would be entirely philosophical, questioning the whole nature of these things, of these questions. And then there would be a more experimental part, that is the psychology behind it. And then we will have the last part, which is the computational part of it, where I try to simulate some of these measures of the brain. So that's the three columns, right? Psychology, philosophy, and the computational neuroscience. And once you put them all together, you can just ask really, really interesting questions. And yeah, they're basically, I see them like my tools. They're like my weapons as a researcher.
I see. And like from my knowledge, like this architecture and neuroscience intersection is getting more and more popular like these days. But how do you keep up with the trends in the field of neuroscience? Like, what are some conference or resources you recommend?
Yeah, exactly. So that's, yeah, excellent. So basically, what I do is that I try to attend to as many conferences as possible in all of these fields. And it's becoming increasingly easier because most of these people are starting to realize that we need cross-disciplinarity, interdisciplinarity. So most of these conferences are becoming more and more interdisciplinary. And of course, for someone like me, that's just a huge advantage. That means I don't have to go to 3 conferences. I can just go to 1 or maybe 2, and I can get my fields covered, and that's really nice. But there are always buts to this case. Certain conferences are just better, or they're typically better for certain topics. And so I guess that I sort of have to make sometimes decisions that, you know, there's a trade-off. Sometimes I have to go to this one instead of the other one. But basically, yeah, so when I have to keep up with the literature, I prefer to, well, obviously, read through the different journals that I know are important to my research, but also try to attend these conferences and contribute whenever I can. So that's basically how I keep up on these 3 different fields. Yeah,
I see. And can you name a few conference and journal which you recommend?
oh yeah, so definitely. I personally am very fond of this International Conference of Spatial Cognition, so the ICSC. Also on the International Association on Empirical Aesthetics, the IEAE. And now I've just recently been, of course, also the ANFA conferences, so the Academy Neuroscience for Architecture, and also the ICSA, which is a conference on structures, built environments that now are also trying to. So they're basically more into construction and building the actual physical part of it, but they're now also opening up to the more, let's say, experiential part of architecture, which is actually pretty cool because in the other conferences, typically who I would meet would be experimental psychologists and cognitive neuroscientists, these kinds of people. But at the last one that I mentioned, is actually typically architects and engineers that show up. For the other parts, oh yeah, there's also small symposiums always showing up here and there, which is really, really important because if you work with computational neuroscience, you will always find certain like small communities of people that are working with specific algorithms, or they have a specific mindset towards the brain, and they sort of work in these small communities. And sometimes there's just not enough people to actually throw a whole conference. So what they would do instead is just throw small symposiums. And there I learned you need Twitter. If you're a scientist or researcher, you need Twitter because everything happens on Twitter. All the announcements of symposiums, interesting conferences, interesting publications, they're all happening on Twitter. So that's the conferences. In terms of journals, I mean, obviously, besides the more popular ones, so like Nature Neuroscience, Human Behavior, Nature, Journal of Vision is something I really started to appreciate. Well, obviously the PNAS, so Proceedings National Academy of Science, scientific reports as well. I think is I mean, there's really, really high quality publications in there as well. So then of course, like Entropy, for example, is also a good one. There's just plenty. Ecological psychology as well. I mean, there's just so many different journals. Yeah.
I see. Yeah, that's a great recommendation list. I'll definitely check out the conference and the journal. And Can you elaborate on the VR plus EEG research of yours and walk us through the whole process?
Oh yeah, sure. Probably what I should mention is also the MOBI conference, because actually that's the
Movie?
one conference, yeah, the MOBI conference, the Mobile Brain Body Imaging Conference, because that conference is where I learned the most.
Oh,
Because people that go there are just so enthusiastic and engaging, right? They really want this. They really love what they're doing, and it's so obvious. I mean, they would pull up their computer right next to their poster and show you something that, I mean, cannot. It's not necessarily related to their poster, but it's something that they really, you know, there's this fire and this passion. And I think that I thought that was really cool. But maybe I should share my screen then. I can show you a couple of things in terms of let me see, of the type of research that I'm doing. Oh, that's the wrong screen, isn't it?
yeah,
Should be screen two. Let's go. Yeah.
perfect.
Can you see it? Yeah.
Yep.
Okay, so I don't know. I don't think that it's necessary to go through all the theoretical work, so all the psychological part, unless you sort of you want me to do that. But I guess I can just skip to the more technological part where I explain how I sort of make use of these technologies. Isn't that better?
Yeah, like a high level overview would be great.
Okay, yeah. Well, I guess I could
Yeah.
say a couple of things then. Yeah. So basically, let me think. All right. So not so much about neuroscience. Maybe this is a good place to start. So basically, there has been this idea of cognition, which is basically one of the topics that I'm very concerned about. Is that we have a passive approach to cognition, which basically means that in the good old days, we would always think of cognition as a sequential, in the sense that there is some perception going on, so we perceive the world, then there is some cognition going on, and then there is some action going on, right? So you basically perceive something, you think about how to respond to it, and then you produce your response. That is the action. So there's like an input and output here, and it's very, very easy to sort of think about conceptually, and it's a very passive approach. So what happened is that at some point people started reconsidering this very structure, this very framework of cognition, and stating that maybe human beings are less machine-like and maybe more dynamic. Maybe we can change our mind based on our actions. And that's interesting, because then it's the action that is actually driving cognition. And that's where the active approach of cognition started to emerge, where basically you could say, well, actually, when you are moving around and you're doing something, that action itself is also producing some perception, right? So it turned things around, and it sort of forced us to ask more, let's say, ecologically valid questions. When I say ecologically valid, I mean that it's no longer your job as a scientist to ask people to sit down in front of a computer, show them something on a screen, and then you present them with two buttons, and they sort of have to click right or left. Now it has more to do with, let's make more ecologically valid experiments where you can actually use your body, because apparently that's what you do in real life, and it has an effect and impact on your cognition. So my view on this is that once you turn the arrows around, we know that perception can cause some action, but now we also understand that action can cause some perception. It essentially just removes the idea of cognition, because now it's no longer some kind of black box going on. Now you can actually think about the action driving the perception, and then the perception moving back again into action, and what you have is a recurrent loop. And that makes things really interesting in terms of, well, both for computational neuroscience, but also in terms of how you actually make your experiments, because you sort of have to rethink all of these experiments. They can no longer just be seated. So that's exactly what the whole MOBI people are doing, right? The mobile brain body imaging people. And here I have to give like a huge credit to the whole Berlin team, because I mean, they're just at the forefront of this particular approach. So basically, the hypothesis that I sort of tried to develop was that we adapt by predicting the actions that cause favorable sensations. And that means that affordances are embodied predictions. So affordances refers to a concept that was introduced by James J. Gibson back in the late 70s, early 80s, where he talks about affordances being a concept that it's a relational concept. So basically, it's between you and the environment or some object, and it can be quantified or characterized by the fit between your physical structure and the physical structure of that environment or object. So I sort of used that concept. It's a relationship between our body structure and the environment. And I thought, maybe let's try to work things around in architecture, because I believe that architecture is basically a landscape of affordances. Can we change those affordances and see what happens with the action potentials in the brain? So basically, if I had to put this in words, my hypothesis would be we should be able to measure systematic changes in the sensory motor regions reflecting the architectural affordances in parallel with perception, right? So that was what I showed before. You would expect actions to affect perception the same way that perception affects action. That's the big hypothesis. And now I'm moving into my experiment. And here I will show you just briefly. I hope that you can use the laser. Typically, people can see the laser. So let me just explain to you about the whole setup. So that's more like the methodology and how we actually set it up. Basically, what we had is a participant here, and we would equip them, in this case, with the mixed reality from Windows. It's back in 2018, so it was not the new one. In terms of tracking, it does not use any lighthouses, so it's from the inside out, using cameras. And then what we had is a mobile EEG. So that's the brain imaging method that we use. EEGs, I don't know if people know what that is, but I can just give a quick recap here. So basically, EEGs consist of small sensors that you place on the scalp, and you can measure brain activity. And if you use some very advanced algorithms, you can learn a lot about what's happening in the brain, because the brain is basically communicating across through synaptic activity, and these will give small action potentials, and especially the postsynaptic action potentials, we can actually measure those through the EEG. But it's obviously not precise in terms of telling you where something is happening in the brain. I mean, these are very simple sensors, which let's not forget. And basically, we attached also a portable computer to the back and some batteries to run the computer. So the computer would be running the VR system and also integrating the EEG signal. And the way that we integrate all the information is through something we call the lab streaming layer. So for anyone who's trying to integrate things into millisecond precision, I would suggest them to look into lab streaming layer. A lot of things has been developed for this, especially a lot of tech things. Super good software. And basically, this made our participants completely portable. They can just move around as they want. And at the lab in Berlin, where this unfolded, we had 120 square meters of just pure walking. You could do whatever you want in that. It's a lot of space. And in there, what I did was that I created an environment where people would stand in front of a door, and they would be introduced. They would face 3 possible doors. So one of the doors was 1.5 meters wide and was easily passable. The second door was passable, but only 1 meter wide. And the last one was only 20 centimeters wide and was completely impossible to pass. Now you have to imagine that all of this is happening in VR. So in real life, they should know that they can pass no matter what. There are no actual walls. Interestingly, no one did. So I take that as at least a marker of sufficient immersion, let's say. So the idea would be that when they stand in front of this door, the door would turn either green or red. When it turns red, it means you should not pass. You should just turn around, and then there would be a virtual questionnaire that they had to answer, and they would start over again. So that would be one trial. If the door turned green, they had to pass through the door, or at least try, because if they had the narrow door, they wouldn't be able to pass. And so they would just fail and go back and then answer the questionnaire and restart. But if they were able to pass, there was a red circle floating around in the air, and their task was basically to go there, touch it with their controller, and it would cause some kind of reward in terms of money. So some euros they would get back. And essentially, once they did that, they had to go back and answer this emotional questionnaire. And this was one trial, right? So they had to do this 240 times. And that's why EEG studies are just so complicated, because you need a lot of trials to get a proper signal to noise ratio. It's just how it is. So once we start looking into this, and now here comes the neuroscientific part. So the architecture part, just to briefly recap again, is changing the affordances of the environment. That's all we did. We only changed the door size, right? So we had 3 possible doors. 2 of them were passable. 1 of them was impossible to pass. I refer to the one that is impossible to pass as the narrow door. Now, interestingly, when we look at these early perceptual processes, we find that it's always only the case for the narrow condition that we can find significant differences in the response. So this is neural response happening at around 100 milliseconds. This is very, very, very fast and very early, right? So it tells us something about what's happening in the brain when you perceive something. And what's interesting here is that affordances, we should not forget, is a motor-related relation, right? So it's a motor-related concept. It has to do with your knowledge about your body and whether you can fit that door or not. It's interesting to see that there is motor information already at this stage of perception. And again, when we looked also at the moment that they get a green door, and then we looked at, well, what happens when people get a green door? And we sort of find this huge difference, again, for only the narrow condition. I mean, it's very clear that the narrow condition is processed in the brain completely different. So it sort of made us think, that's really interesting. How come that the brain is processing affordances in that sense? And of course, I was criticized for this experiment to be very static, like in the sense that you just never just stand in front of a door. There has to be some kind of continuity in your experience with the world. And I thought that's true. So let me analyze what happens from the moment that the people perceive the door and they start walking. What happens in that phase? And I started looking, so this is maybe, I can use this diagram here to sort of explain what's going on. So basically we have a mobile phase and an immobile, they're standing still, and we have a mobile phase, right? So you have to imagine that they're just here at this point in time, they just perceive the door. Then they're waiting to get the go signal or no go signal. Then it shows up the go or no go. Let's imagine for the sake of this example that they get a go. Then they start walking and they will reach the threshold. This is where they actually pass the door. And we start looking into, so basically what is happening in the brain. So one thing is that we located some so these are the sensory cortex part of the brain and the motor cortex of the brain. We find this is exactly where we find the significant differences again. So it totally matches up with our hypothesis. Then we start looking into the time frequency analysis. So basically your brain is always communicating again across different areas using these frequencies. And what we found is that the alpha frequency, which is this band that is running right here, was highly, highly pronounced for during the moment that they perceived the door and they were just standing there looking at it. There was, for some reason, a very, very pronounced alpha. And the alpha frequency band is typically associated with attention. So it's an attentional mechanism. And we thought, that's interesting. Let's see what happens while they are walking towards the door. And once again, we find actually an even stronger attentional mechanism because they sort of have to be aware of what's happening. And this is what I thought was really, really interesting. So we start looking into these continuous processes of the brain. And it's interesting because the first experiment sort of tells us that the brain, when it has to figure out what it is perceiving, it is also figuring out how can I act. So the idea of how can I, the idea of what do I perceive and how can I act are parallel processes. This is really interesting from many points of perspective, right? And also we found that it is a continuous impact of the architecture. So the architecture is continuously affecting us. It's not something that it's not like we need to pay attention to something. It's always there, right? This is what's one of the unique things about architecture. It's just always there. Yeah, so these are the two main experiments. Now I just scratched the surface here of these two experiments, but I don't know if you have some specific questions or you want me to explain something else or.
No, this is like, first of all, amazing, incredible research. Great job on it. I was thinking on the lines like, so once we know this information about attention, like how would you use this for your future architecture design?
That's a really good question. So my idea is to now sort of pick that phenomenon, attention, which by the way is the worst. Because it's a phenomenon that everybody thinks they know what it is, but once we actually start questioning what is it, nobody really knows what it is. So there is this very, very extreme polars about what we think of attention. Either everybody knows what it is or no one knows what it is. But anyway, I started looking into it and sort of figuring out, so how can we create a paradigm, a new experiment that sort of looks into attentional mechanisms and how they can be affected by architecture. And this is not trivial. I mean, this is not an easy task at all, because you need to come up with very intelligent experiments. The worst thing you can do is basically just to throw people into, like, I don't know, noisy cities and measure the brain, and you have no clue of what you're measuring, because it's just so many things going on. And the brain just is constantly active, and it's very, very difficult to say anything specific. So what I started doing is actually diving into attention and what does attention mean. And I thought, let's look into this. So I thought maybe the attention has something to do with the gating process, right? This is some of the theoretical work behind attention. The main idea behind the gating theory is that your brain is basically filtering out information that it doesn't need. Like, for example, right now I'm wearing glasses, earbuds, and I'm wearing clothes and all these things, but I don't necessarily pay attention to the way that they feel on my body because I'm doing something else. So I'm filtering all that information out. Now, the question is, are we also filtering out all that information about the environment just because we're not necessarily paying attention to it? And I thought that what could be an interesting way of investigating this is to see, oh yeah, so maybe I should mention that typically what we associate with attention is change. When something changes, for some reason we pay attention to it, right? Oh, that was like, oh, something is missing. Something was there just before. I don't know what it was, but something changed. So change can cause some kind of interest for us. So basically, let me give you an architecture example of how change actually is something that architects modulate all the time for us as users. So here's an example of Times Square in the US, in NYC, New York City, and this is Vesterbro in Copenhagen, Denmark. Basically, the main difference between these two cities is that one is a victim of modernism, the other is not. This one is a victim of modernism and basically is constrained by this huge grid that has been put down over the city, whereas Copenhagen grew organically and very naturally as more people moved into the city. It sort of gives two very different layouts of the city. This one has a lot of basically almost only 90-degree turns. When you walk down here, it's clearly not made for human beings. It's clearly made for cars and for cars to move around quite fast. But over here, you have something that is made for people, and you would quite typically find turns like this that are like 120 degrees or 20 degrees, you would say. So very soft turns. And what does that mean? It means that the way that we process the information will cause a longer delay here. You have to imagine that how much new information am I getting from the environment? Well, in a relatively short time, if you are in New York City, you make that 90-degree turn, you get a lot of new information in a relatively short time. But here your turns are very slow. So you get a slow information over a longer time. So this is basically just to illustrate what would that look like. So the 90-degree turn happens here, and here there's this more, let's call it slow turns, can happen in Vesterbro, right? So we're basically modulating the velocity of sensory information. So this is, we're basically modulating the way that people experience change in the environment. This is what I'm trying to reach. This is the main point of this diagram. And I thought, well, I can for sure simulate this. And I thought, let me make different kinds of turns. There's an agent here who's walking around and is basically transitioning from one room to another. And as they are transitioning, I'm basically collecting or storing the velocity of the sensory information, which you can see down here. It's a fairly easy simulation, I think, and most people can redo this to sort of confirm or falsify my study here. And basically, when I look at the parameter analysis of these three different turns, I basically look at how fast is the sensory information being processed. And it's really incredible that small turns like that actually made a huge difference. And I thought this is something I need to check out with real people. So again, I'm coming back to the three-pillar scientist. I like to do things theoretically first, I simulate it, and then I'll go out and do actual neuroscience with it. So I thought, okay, how do I test attentional mechanisms? There is something called the Postner's paradigm, which basically I will just quickly explain it here. By the way, Mayur, you have to tell me if I'm talking a lot.
No, you're like, it's going great. Just
let me know. Yeah, questions or whatever. Yeah, because I have a tendency, I can talk a lot about this topic. But anyway, the Postner's paradigm is basically you have people staring at a screen and you ask them to focus on this cross. At some point in time, an arrow will show up, and the arrow will point either to the right or to the left. and then some stimulus will show up, and basically you have to click the button where it shows up. So in this case, you would click on the right side, the right arrow on your keyboard. And only 20% of the times would this arrow tell you the truth. 20% of the time, it will not tell you the truth. And we quickly learned that. So it's a very good way of sort of looking into spatial cueing, as it's called. So this is the endogenous version, which basically means that the cue is showing up within your visual field. What happens when we change that to a cue that is outside the visual field? Well, we get that the same effect actually happens. And that's interesting. I thought, well, let's look at maybe an embodied cueing, right? So can we use the environment to sort of increase or decrease people's attention or their reaction times? Because this is basically where the main effect is basically reaction times. Right. So I thought, let's do an embodied cueing. And this is the experiment that I'm basically working on right now. You are walking from one space into another. You have 3 different angles. One is very sharp, 90 degrees. The other one is less sharp, it's 45. And the last one is sort of straight, it's a 20 degree. And as you are walking, basically these small stimulus are showing up one after the other. And I ask you to sort of click your controllers accordingly. And it's really interesting because I started now looking into my pilot data, and the effect is so strong. It's unbelievable. It's really interesting. I promise you there will be a very good publication soon about this. But what's interesting about this is the environment is modulating attention. That's just mind-blowing as an architect to know that, well, you have that power, you know. And then the question is a lot of questions starts to surface, right? Because we've been building architecture for many years, but no one had a clue about what it looked like or what kind of effect it would have on our brain. And now we're starting to uncover some of these things, and it makes you question, well, maybe it wasn't a stupid idea that I didn't go for an architect career. Well, basically, I don't know the effect, and I could have been causing like harm to people, and I could have been like causing, I wouldn't say harm, maybe that's dragging it too far, right? I'm just pushing it now, but maybe my spaces would not be optimized to the function because I don't know about these effects. I don't know about like what spatial configurations would you need in order to increase attention, right? So these are some of the preliminary studies that we need. And I thought, well, if no one else is going to do it, I'm going to do it. Anyway.
And this is much needed, like when we are designing spaces, like some of the design moves we have like can increase like cognitive stress. So
like cognitive load is typically something that a lot of neuroscientists or experimental psychologists like to discuss. And it turns out that the environment can in fact modulate that load. And it's interesting that no one has really tried to figure out what's the relationship between architecture and that load, because we can never escape architecture and it's always there, right? So it's like brain, body, environment, and you have that bidirectional relationship between all of these 3 things. So we can't just put out the word. You can't just cross out the world. It's because you're always situated. You're always embedded. Yeah. So anyway, we basically looked into the neural mechanisms here and the neural network that sort of emerges from spatial cognition, and now we're working on trying to figure out, well, exactly what pieces of the brain is involved in some of these attentional mechanisms. So this is how, at least now, I'm trying to concretize, I guess you could say, some of my discoveries into actual architecture that is not necessarily centered around door sizes and stuff like that.
I see. And like I always like wonder, many times neuroscientists do research in a controlled environment, and how do you scale your research in a test environment to real life, because there are a lot of unknowns and noise that could also like be part of that environment?
Yeah, that's a great question. So basically, I guess my philosophy has been that we start in the lab. And we identify specific mechanisms, specific markers, specific physiological measures that we can rely on. It's sort of like saying we start in the lab to know what to look for once we get out of the lab. because it's a more controlled environment. It just makes things much easier. So the idea now is to move from VR into AR, and we're already working on this right now because especially now with this paradigm working, we know that we can use something like that for an AR environment. But then again, the question becomes, well, what kinds of AR environments are you going to look at? And when you want to do comparison between two groups, you need to vary only the architecture. Otherwise, you can't say that architecture created the effect, right? So you need to only change one variable at a time. But if you change the architecture too much, then what happens? Then what part of that architecture actually caused that effect? And this is something that I'm still struggling with.
I see. And this question might be a bit off topic, but I see a lot of development of like metaverse assets and VR headsets for that metaverse. So what's your speculation on like in the metaverse, if every building or asset is trying hard to fight for the attention and trying to be unique, is it gonna be a lot of cognitive load, or is it gonna be like a great curiosity driven experience?
Oh yeah, of course there is that aspect of yeah, metaverse is now taking over the world. Yeah. So I guess it will be very difficult to say right now because I have not personally looked into any papers or anything like that myself. It's going to be interesting. Well, because yeah, I mean, you will yeah, you can control basically the environment to a much greater detail than what we can right now, which means that well, the architects become. I like to think of architects as those who sort of design the narratives of our lives, but in that case, it's like literally what they're doing, like almost every detail of it. So I don't know exactly what to expect from something like that. I guess it's going to be a bit difficult to speculate on. But I guess that if we yeah. So let's imagine that we figure out something specific, right, from these experiments. I can imagine that someone would exploit it in one way or another in order to do, I don't know, make you buy things more or something like that. I don't know. But I mean, this is always the case with any discovery, right? Because I guess anyone would like to make money of it or something like that. There will always be someone who you know abuses the discovery.
Especially, I could foresee like if from the study one could find where is the spot where people have most attention. That's a great spot for marketing and advertisement in that area.
Exactly. I mean, yeah. So unfortunately, I am indirectly contributing to people that think in that direction. It's not my personal view on things, but I guess it's inevitable.
But like I could also see like there's always like pros and cons like of a thing, but like this could also help architects in design and planning states for better spatial curation and
Yeah.
like assembly. Yeah.
Yeah, exactly. So that's definitely one of the goals, right? Navigating cities and navigating spaces in general. I've been specifically looking a lot into Alzheimer's to understand better how are the navigational skills and how can we help them navigate spaces even or navigate their attention, which is then what they will use for navigating spaces. So yeah, this is definitely one of the things that I'm also looking into.
I see. And if you had like unlimited time and resources, what are some other future research ideas or problems you would like to work?
Whew, yeah, if I had unlimited, yeah. Good question. I guess the idea of having unlimited resources is so unrealistic to me. I haven't even thought about it. Well, I don't know, actually. I have a lot of ideas about how to investigate architecture because my impression, or actually, yeah, my opinion is that there is no one out there doing proper architectural research, myself included. Simply because I think that architecture is so complex that every time we try to do something with it, we're reducing it to something specific. So in my opinion, yeah, if I had like unlimited resources and stuff like that, I would try to, I don't know, hire a team to help me figure out exactly what, like, can we come up with a more inclusive definition of architecture in order to test it? Because I mean, it's smell, it's touch, it's multi-sensory, right? It's integration of sensations. There's so many things about architecture. So if I had unlimited resources, I would throw all that unlimited resource at people who can help us understand architecture better.
I see. And like, how do you envision like the research and findings from neuroscience field and profession? Like, how would they collaborate? Like, do you envision like a consultant role where people will hire neuroscientists to guide and help in spatial design, or like
I mean, that's a great question. Yeah. The way that I see it is that a first step would be that I can imagine that they would hire consultants. Could be anything from an environmental psychologist to an actual cognitive neuroscientist, someone who works empirically and has insights into the literature and sort of understands the literature and the current state of it. But I imagine that in the future, like if we go even beyond that part of consultancies, I would expect, in fact, studios to have their own research and development departments where they would take that part much more seriously. I mean, what you see right now is a lot of studios hiring a lot of engineers and also computational scientists to analyze the performance of the building.
Mm-hmm.
Basically, they look into energy consumption, they look into the CO2 levels, they look into sun illuminance, radiation, they look into all of these aspects that are all sort of anchored in the building. And in my opinion, we're missing basically the main point, right? Someone's going to use it. And all of these simulations, you can throw them out the window if the user is not going to adhere. If the user is not going to use the building as you plan for them to use it, all your calculations are wrong. And this is something that is so, I mean, and I think a lot of architects are now sort of realizing that it's a bad investment just looking at the building, because essentially all of these results are just, you know, wrong, plain wrong. If the user is going to use it differently, it's not going to, I mean, the energy consumption is going to sky rise, you know what I mean?
And that's so true. Like, and there's also like, I hardly see a post-occupancy feedback loop in the design cycle where the spatial experience you imagine versus actual, and what were the things that didn't go right, how can we learn from that lessons and work on the future design. Like that loop is like important. Yeah.
And the truth is that architects, they work with tools. So once you create a tool that can simulate energy levels, people will use it. If you can create a tool that analyzes sun, heat, all of these things, lights, people will use it. And if you're lucky, they will integrate it into their design process. So I guess that one thing that I probably am responsible for is I have not developed a tool that can sort of help us understand it from the more human-centered approach, like the user-oriented approach. So this is obviously something that I'm also looking into, right? So for example, you saw the simulation. Once I start to associate those simulation dynamics with a specific type of behavior or specific type of cognitive state or something like that, we will come closer to what might be a tool later. But I mean, obviously, there's a lot of things, underlying things that are still very needed before we can get there. But my main point is that you need first to develop the tools before architects sort of take that seriously. And yet, I still think that I actually insist that architect studios, they try to hire someone with an interest in the human being. If they're not going to take that interest, then hire someone who has that interest and learn from them. Take that more seriously. It's going to improve everything.
Yeah, like it's so much important, but it's so much underrated or undervalued. Like,
oh yeah, for sure. That's my point. That's my point. Yeah.
I'm curious to know your thoughts, and it might be very subjective from project to project. But let's say there's an office building where architects need to design, and if they hire a neuro consultant, like what's the general research phase like or duration for that study?
Oh yeah, okay. So yeah, so for the neuroscientist or for the investigator, let's just call it investigator, the researcher. Like you're asking for the duration of how long would it take to figure out anything about that
Yeah.
space. Well, I mean, so this is where things, okay, I can just unshare my screen, right?
Yeah.
Yeah, because this is where things get really complicated. So there's always some kind of intention behind the spaces by the architect. I want them to use it in this way or in that way, and so on and so on. Now, what you could do as a smart thing as an architect is to hire that researcher to figure out whether it is used in that way. And if not, then what is it used for then, right? What is the unexpected outcome? And can we learn from that? And most likely you will learn from that. The question is, how do you intend to investigate it? And this is where the technology people comes in, because you can run simulations and you can look at these simulations. They're cost free, they're fast, you can do whatever. On the other hand, we don't have these tools yet, as I said, so maybe that's a problem. But you could put them, you could also investigate this using, well, VR, AR, prototypes. There's a lot of things you can do, and depending on your approach, they will have different durations.
I see. Makes a lot of sense. And especially the AEC industry is not well known for like open source tools, open source data sets. So it's causes another challenge in this layer, but things are working well. So I would like to wrap up the interview with few light questions and just fun questions at the end. And it's kind of a rapid fire. So my first question is, which city is in your travel bucket list?
Oh, that's a good question. Well, you know, as an architect, I have traveled quite a lot of places. A place that is still unexplored from my part would be, South America. And now you're asking me because I suppose that you're anticipating I would come up with a very cool city, but I actually don't know which city is like more attractive than another. There's probably no measure for that either way, but I guess I am a bit so for example, Mexico City is something that I've found very fascinating when I read about it. I mean, just the sheer size of it, right? It's so big and so many people living there. I'm curious actually about how, like, the infrastructure, how does it actually work when you have that many people living in such places? And also given their their ecology, right? So their landscape and where they are situated in the environment is actually also quite interesting, because they're living in amazing area with amazing nature. So if I had to come up with something from the top of my head, I guess I would say Mexico City. Speaking of unlimited resources, right? If I could just fly, maybe Mexico City, yeah.
Yeah, like I was in Mexico traveling for a month, and it's amazing. Like,
yeah, okay.
The culture, nature, you would love it.
Yeah, okay, great.
So my next question is, let's say if you close your eyes, and if I were to ask, what is one building or urban space which has the most memory associated with you? Like, what would that be?
Oh, okay, yeah. I already know the answer to that. I would actually advise everyone to experience that. So if people ever go to Japan, go to Naoshima. Naoshima is a place that is just magical, in my opinion. I mean, Tadao Ando, I guess if people are architects, they know Tadao Ando. In my opinion, is just genius. I mean, his sense of his understanding of how space sort of acts as a backdrop to our life is just amazing. And it's so clear that he has understood very implicit things that many architects have been thinking about. I mean, the way that he works with transitions, especially, right? So I'm very fascinated by transitions. I think that basically the human experience rests on the idea of transitions, because transitions characterize dynamics, and dynamics basically means the pattern of change. So the way that things change is going to be what your experience is about. So that's why I think that transitions in architecture are extremely important. And in my opinion, he is just, I don't know, the best transist ever.
I see. And definitely, like, spatial experience. I follow Tarawando, and it's amazing. So my next question is totally opposite. Like, what's the worst place which had like cognitive load on you?
That's a difficult one because there I can mention a lot. There's a lot of bad places in my opinion. So a lot of places are like you will have features of the space just screaming for attention all the time, and it can feel very noisy and incoherent. And something that really bugs me, and now you know that there's actually a couple of studies showing that brains of the architects are simply wired differently than others. We are just way more attentive of space and we tend so architects tend to think more in terms of spaces and they're more visually oriented than most people, uh, which by the way means that whenever you do an experiment you have to exclude architects because they will be more attentive to space. You don't want that anyway. A lot of spaces are just chaotic. There are a lot of incoherence, a lot of it's just a bad composition that is not non-harmonic. Maybe I shouldn't use that word because it's associated with the golden ratio and stuff like that. It's not what I mean. What I mean is like a space that is like more that rests in itself, right? You know what I mean? So it's a space that
Mhm.
knows what it wants to do and it knows what it's doing and is sort of leading you. And that is the kind of space that I like, right? Something that is more leading and not trying to throw in a lot of things. Imagine like Times Square of New York. If you go to Tokyo, like in the city center, I can't remember Shibuya, I think it was called. I can't remember. Big crosswalk, a lot of people, a lot of banners, a lot of noise, a lot of things. And in my opinion, all of these things, it's not that they're bad, but it's not my preferred places at all.
Yeah, and it's interesting that you mentioned that a lot of times, like that Times Square is also like very crowded and a very touristy place. So there's some aspect which attracts people, but is it like the popularity, even though there's a cognitive load, people still like to take photos? Like it's interesting.
Mm. Yeah, I mean that's a phenomenon in itself, right? What attracts people to certain spaces? I think that's a lifelong question.
I see. And is there any book which made a huge impact in your life?
Ooh, uh, there's a lot of books that have made a huge impact on my life. That's a tough one. I can't just mention one because, like I said, I'm a three-pillar scientist, right? So
Yeah.
there's definitely so Henry Bergson, a philosopher from the late 1800s, early 1900s, to the 20th century. Philosopher talking a lot about time and movement. And I think that my readings of his work really sort of made me sure that, okay, what I want to work with is definitely related to time and to movement. Because I saw through, I mean, I understood his arguments. I completely agreed with a lot of things. Of course, he was wrong on many things as well. I mean, we're talking about 100 years back, more than 100 years back, and we know better now. But his main ideas, they are still true. There is still coherence through continuity, and these are some of the most important things that I consider. And actually, I think that they colored completely my way of thinking in so many ways. In fact, I think that they colored the way that I live, to be honest.
I see. And like, what is your piece of advice for masters and PhD students who are interested in this domain?
Who are interested in this domain? Oh, yeah, okay. So you mean at the cross section of architecture and neuroscience? Yeah.
Mhm.
Code. You need to know how to code. If you can't code, don't be afraid of coding. It's not. I mean, obviously, it's the level of difficulty depends on your ambitions and your passion for it, but also I guess on unknown parameters. But don't feel like don't get afraid of coding. It's really important that you sort of just try to do like a simple thing like hello world, spring, whatever. Some of these small steps. Never try to do a lot of big difficult things. Just take small steps and you will get much further. But coding is definitely needed, both in terms of doing research, because of all the statistical things you also need to sort of code, but also in terms of doing VR, AR, and also like doing the actual analysis of the brain. So my yeah, I guess my advice would be learn how to code. Python, MATLAB, C sharp. Yeah.
Mhm. I see. And like, I could totally agree with that. And my last two questions are like, first is if people are not able to afford like hiring a neuroscientist consultant. There are a lot of commodity buildings where we need to deliver like in a very short period of time, quick buildings and less time for research. So how would one navigate in those situations?
You mean like in terms as an architect or as a researcher?
As an architect, like if you have like deliverables, you don't have time, you need to produce fast, so how would they integrate this research?
Yeah, I mean, obviously, if you are like constrained by time, quality is at stake. It's a trade-off, right? The more time you have, the more likely you are going to produce something of high quality. The less time you have, the less quality is going to be integrated into that project. So it's a difficult question because I guess it depends on who you are as an architect, and would you even at all produce something if you know that what you're going to produce is going to be crap. I guess there's also a moral some ethical things behind this as well. But yeah, you see, once again, if we had some tools, if only someone would develop that, I'm working on it. We could do something, at least secure some kind of quality.
Got it. Yeah, some tool which has some metrics of spatial quality check would be awesome. But
yeah, maybe that's too ambitious, but something like that. I agree with you. Yeah, it's what I'm trying to say. Yeah.
Awesome. So is there anything else which we didn't cover in this interview and would like to share?
I would also advise people to sort of do not neglect theory. And it might be so that I'm asking a lot for people who are going into this field, but people who are aware of theory will quickly realize how bad we're doing in neuroarchitecture, as they like to call it. I completely disagree with the term, but it's fine, we can use it. I mean, it's obviously bad. There's so many things lacking, so much bad research. Maybe I shouldn't call it bad, but let's say unscientific. It's research nonetheless, and it's fine, it's good. I mean, I'd rather have that kind of research than nothing at all. But we don't have anyone, or at least people not trying hard enough, I guess you could say, on doing proper research. I mean, proper science, like working systematically, working deductively. I'm not saying that inductive research is not science. I'm just saying that you can't say anything specific from that. If you just do exploratory work, you sort of need to take it as fine, because you will realize, you'll observe there is something here of interest, but then you need to take it to the next step. That which you found interesting, can you do a systematic variation of it and see if there is anything you can say? And these are some of the things that are lacking. I mean, you would be surprised to see how little there is.
Oh my God, that's a great point you made. Like, I have not looked much into the research, but I can totally agree. Like with the AI research and other field, I am more aware. Like having strong theoretical background is a must, I would say. Like, yeah. So yeah, thanks a lot, Zach. It was a great interview. I had so many new knowledge and insights gained through your presentation, through your thoughts. So thanks a lot for sharing.
No, thank you for inviting me. It's a pleasure, really.
Yeah. Have a nice rest of your day. Take care.
Yeah, you too. All right.